The Level 2 Large Load Alert Informational Webinar hosted by the NERC engineering team. Just want to make sure that folks understand that this webinar is being recorded, as we will be being able to share this for folks that were not able to attend this webinar, as this largely is a way for the industry to ask questions from the NERC engineering team about the content that is in the Level 2 Large Load Alert, and really answer some of those burning questions. Like many of our other NERC activities, this activity will be governed under our antitrust compliance guidance. You can find that on our NERC.com webpage, or you can email myself, and that is john.skeeth@nerc.net, for a PDF copy of that document if you need a PDF copy. So again, I wanted to welcome everybody here. NERC, over the past year or so, we've prioritized various different activities related to large loads, all which are focused on the support of a reliable interconnection of growing large load capacity and the various customers that are coming on to the transmission system. And this Level 2 Large Load Alert was one of such activities. And I'll continue to go into that a little bit more. But on the next slide, I just want to give a quick introductions for our panelists here. I am JP Skeeth, the manager of the engineering and security integration team on the engineering half of that equation. I'm joined with fellow panelists, Hasala Dharmawan, sorry, Hasala, for your last name, as well as Jack Gidfried and Evan Mickelson. I would ask Hasala, Jack, and Evan to come off mute and introduce themselves.
Yeah, sure, I'll go. Yep, Jack Gidfried. I'm an engineer, work under JP on the engineering team at NERC. I help coordinate the Large Loads Task Force and work in other activities as well. But very excited to be able to share more with you about this alert.
Over to you, Hasla.
Folks, my name is Hasla Dharmardhan, and I'm a senior engineer in JP's team. So excited to be part of this conversation. So we want to help you guys. If you have any questions, please do not hesitate to reach out and add that in the Q&A, and then make sure that everybody gets an opportunity to get an answer. Because if you have a question, it's probably shared across many other folks too. So please do reach out. Please do share your questions. All right, thank you, JP. Over to you.
Thank you. And Evan, if you wouldn't mind introducing yourself.
Yeah, I'm Evan Mickelson. I also work on JP's team. And I, just like Jack, am also coordinating with the NERC Large Loads Task Force. So it's a pleasure to be here, and thank you so much.
Thank you all. Today we're largely going to go over the content of the Level 2 alert to refresh us all for the scope of our conversations here. We'll then answer some of the frequently asked questions that we got at the engineering@nerc.net email list regarding the alert, and then we'll open it up to the audience for any questions that they want to answer. And the way you'll do that is enter your question into the Q&A tab at the bottom right. So it may not auto-populate when you opened up WebEx, but at the bottom right of your screen, you should see a Q&A button. If you click that, you should be able to see all of the Q&A and a box where you can enter in your question. Those will be able to be visible throughout the webinar. And so we'll do our best to answer every question that we get verbally. But to give you all plenty of time, we ask that you start placing your questions that you may already have in that window already as we continue our review and in our frequently asked questions section. That way, we're able to see your questions as early as possible and get them ready for the open session. So on the next slide, please. I just wanted to give a brief overview of the alert. And generally why this alert occurred and why NERC chose this vehicle to share the information related to the study, interconnection process, and operational readiness of large loads. We see NERC's mission is to assure the effective and efficient reduction of risks to the reliability and security of the North American bulk power system. We saw over the last year a significant rise in demand associated with large loads. And so the way NERC accomplishes its general mission is through various mechanisms. One is to develop and enforce reliability standards, another to assess the current and future reliability of the system. Third is to analyze system events and recommend improvements to any practices. And the fourth is encouragement of active participation by all stakeholders. And so this alert largely is part of those third and fourth items, where we've assessed known events and we're recommending a industry practice through the level 2 alert, and is encouraging significant participation. And it's coupled with the participation in NERC's Large Loads Task Force. So a lot of the content was sourced from the engagement that we have received within the Large Loads Task Force. And that is under the NERC Reliability and Security Technical Committee, solely focused on the rise of data center large loads, as well as other large loads that would have met their definition. However, the primary class of loads that this Large Load Task Force has dealt with is data center or data center hosted algorithms and their various demand profiles. Excuse me. On the next slide, we'll show a little bit of those events that we've analyzed. On the right-hand side, we'll start there. Over the last few years, we've identified a few data center load loss events within the Eastern Interconnection, as well as multiple crypto mining center load loss within the Texas Interconnection, as well as kind of totaled 100 to 400 megawatts of various different demands for however those crypto mining facilities were operating during that period. The two larger ones in the Eastern Interconnection, and there's been subsequent events that are not listed here on this page, but these are the two initiating type of events: a 1,500 megawatt large load aggregate loss, and that was in July of 2024, and this 1,800 megawatt loss, and that was analyzed to follow up in February of this year. And so these system events largely showed a common sensitivity to tripping or load reduction, as many of these customer owners or facility owners went into a customer initiated load reduction and swapped on over into either backup power or disconnected its electric service based on a different signal or in response to a grid phenomenon. These are sizable losses, and we kind of needed to see where the system was going for its increasing amount of demand. And so we looked to our LTRA, and on the left-hand side is a figure that shows the rapid growth of crypto data centers, other large industrial loads, areas where transportation electrification or aggregate amounts of EVs or fleet electrification may play into an account here, as well as heat pumps specifically in the American Northeastern region. We also see larger demand increases and demographic changes. However, the Large Loads Task Force and a lot of our efforts have been focused on the data centers, crypto aspects, as that's kind of seen throughout. We do have a separate effort for transportation electrification, yet that is not the content of the Large Loads Level 2 alerts, as those are based on the white paper that the LLTF provided for the characteristics and risks of emerging large loads, which do have a generalized definition that largely is not the same problem as an aggregate amount of individual EVs or individual fleets that have been electrifying. On the next slide, we'll show how this all plays out into a broader plan, where the alert is one piece of the various plan. Now, I've been talking a lot about the Large Loads Task Force, and that is a major key factor of NERC's Large Loads Action Plan. It does plan to operate, and it started operating late in 2024 for its kickoff, and has been working all throughout 2025 to produce high quality papers and a reliability guideline that is out for preliminary guidance. And it plans to end its activities in the middle of 2026 for its current work plan. Alongside this in our action plan, we identify that collaborative industry sessions are necessary throughout this year to identify the scope, size, and recommended practices for mitigation of risk that the LLTF or other industry segments or stakeholders have provided to us. We further looked at our legal basis for registration of this type of asset, primarily in ensuring that our set of registration criteria is fully appropriate, and that includes some consideration of the load serving entity and the applicability of that type of analysis throughout the year. And other complementary activities, including this large load level 2 alert, are the ongoing nature of our large loads action plan. And so you can see that this alert is a way to share industry recommendations that have come out of coordination with industry stakeholders through the Large Loads Task Force and other collaborative industry sessions in a standardized and a way that allows us to assess the current nature of integration practices with large loads, as well as seeing how entities will be adopting some of the items that are in the large loads level 2 alert. On the next slide, I just want to give a brief overview of the categories of alerts. And so since we have recommended practices that we wish to share that have been built off of that industry stakeholder collaboration, we've released this alert as a level 2 alert. That is a recommendation to industry, and that's in the middle of your screen here. NERC has 3 different categories of alerts. The first, on the left-hand side, is an advisory. It's an informational intended to give registered entities and alert entities to ongoing or potential problems with a response not being necessary to such a level 1 alert. Level 2 alerts do provide recommended specific actions for entities to take. A response from the alert recipients as defined in the alert is required. And that is the category of alert that we've released for large load interconnections studies and operational readiness. Further, we have a level 3 alert, which is in essential actions. So those are recommendations that are deemed to be essential for bulk power system reliability. Those would require a NERC Board of Trustees approval prior to their issuance. And like the level 2 alert, a response from recipients would be required based on the alert. So let's get into the content of the level 2 alert itself. As I gave you kind of the background and where the alerts fit in the broader strategy in the large loads action plan. This alert provides guidance in ensuring reliable integration of large loads. And so it's based on that LLTF white paper of the characteristics and risks of emerging large loads. It has recommended practices for interconnection requirements, study process, and commissioning requirements, including items for planning studies and the respective models that need to fuel those studies, as well as a look to improving the operational readiness of large loads as they near their energization and commercial operation date and throughout their commercial operations and how they relate to our operating entities of the transmission system. The content of this alert is aligned with that initial white paper and the ongoing work with the large loads action plan. And it does allow us to collect data and analyze the conditions for all of our registered entities, specifically on how the processes for load interconnection applications, as well as like the generalized customer management of large load customers, are taking place within our transmission owning utilities. We anticipate to assess the current landscape of how large load owners and operators are engaging with their transmission owners to provide data, practices, operational changes, and otherwise including their operational readiness to the entities that would be responsible for operating or planning the system through the responses to this alert. And that is why this alert does have a significant amount of questions, given that it is pretty broad for planning, operations, study, commissioning, and has many different topics. Certain portions of the questions are applicable to entities registered as that particular function. Some questions are generic, and so they would be repeated throughout each individual registration. For instance, if an entity was registered as a transmission operator and a balancing authority, there were questions that are specific to transmission operators and balancing authorities and joint between the two. Where repeated, entities can provide additional context based on the function that they are performing. However, it is unnecessary to continue to repeat the same answer. You can always refer us back in that sheet to the original answer for that one entity. So that is overall of the alert. The alert does provide that initial definition and a few 5 total recommendations. If we go into the next slide, please, I want to share it. It provides this definition of large loads and does not provide a demand threshold associated with it. So this large load definition came from the Large Loads Task Force as any commercial or industrial individual load facility or aggregation of load facilities at a single site behind one or more points of interconnection that can pose reliability risks to the bulk power system due to its demand, operational characteristics, or other factors. And as you saw there, there's not a particular demand threshold set. While that is potentially needed for reliability standards, state or federal regulation, as well as NERC registration, for the risks associated with this category of assets, the LLTF did not see it appropriate to identify a demand threshold at this time. So the risk is based on the quantity of demand and its operational characteristics. And that is the key that came out of the LLTF. And that's why you don't see necessarily in the definition a bright line demand threshold. However, we do acknowledge that if an entity did not have a megawatt threshold, we do provide some guidance in what is required to be reported to us that would meet a large load. So let's get into our recommendations on the next slide. The LLTF came back with three categories of risk: a high priority, medium priority, and low priority risks. The 5 of our recommendations are essentially summarized as recommendation 1, to establish clear facility design and performance criteria in their interconnection requirements for large loads to mitigate various different risks. So it was largely for transmission owners to establish clear design and performance criteria for large loads that are seeking interconnection, and it requires some coordination of those requirements based on the various risk factors that the LLTF found. The second is that transmission planners and planning coordinators should establish an interconnection and system-wide study process using our typical steady state, transient dynamic, or short circuit models to assess the reliability impacts of large loads. And there's some subsequent items there for how we envision that study to proceed. The third recommendation being that as part of the transmission owner's role to establish load commissioning activities and establish a comprehensive commissioning process to ensure operational readiness for large loads. And so that would include a lot more of the coordination with our operating entities to ensure the commissioning activities done to commission the large load facility, ensure that our operating entities are able to engage and otherwise monitor and operate the transmission system in the presence of these new large loads. Our fourth recommendation is that the transmission owners should also establish operating protocols and the necessary communications infrastructure to support that reliable operation. And that is primarily about SCADA plus other, if necessary, EMS type coordination to ensure proper monitoring and inclusion into a transmission owner's, a transmission operator's duties. And the reason we would need the transmission owner to do that is that the equipment that is being used to then send the data to our operating facilities, we would need to have a transmission owner to have those processes in place for large loads. And then the fifth recommendation is broadly, when we view forecasting, we would need to see the near-term and long-term horizon, some sort of demand forecast. And so our fifth recommendation is broadly, we need entities to communicate and coordinate to ensure when and where large loads are coming onto the system so that way we can adequately plan the resources and transmission investment and otherwise keep the bulk power system reliable with the increase of this demand. So those 5 recommendations that I kind of overviewed here fit this left-hand category, the high category, where we see resource adequacy, the balancing of reserves impacts, ride-through stability, voltage stability, angular stability, and generalized oscillations. And so each of those 5 requirements are kind of embedded with this high category of risks, where we see we need to procure the right resources, ensure transient stability of our system, excuse me, and to make sure that we have the proper interconnection processes to make these high priority risks mitigated through our set of entities. Now, there's some medium risks in here that are captured and inclusive of that demand forecasting on that final recommendation. But a lot of those recommendations are focused on the high priority risks, and some of the medium priority risks are likely captured with this comprehensive study process and commissioning practices. On the next slide, I just want to overview a little bit of these risks and generally how our large load level 2 alert might cover them. So in long-term planning for resource adequacy, we saw that these large load facilities would interconnect much quicker than resources could be used to build to supply the energy and/or ancillary services for those large loads. Now, this is essentially a problem of when we don't have sufficient resources, what do we do to invest and build those resource adequacy items? And we've highlighted resource adequacy challenges in the past from NERC. And so part of our level 2 alert is to ensure that the facility interconnection process is done in a reliable way so that these faster building resources are able to integrate effectively and reliably throughout the entirety of the project lifecycle. And that could include a phased approach while certain lines or other resources are built in order to supply the energy or otherwise bolster the bulk power system to maintain stability for reliability purposes. On the next slide, we'll see an operations and balancing where we see that a lot of the large loads do vary their load significantly between almost no current exchange up until their full rated capacity, well within the typical 5 or 15-minute type dispatches that we would see some variation for. This largely affects our balancing authorities who need to procure enough negative reserves or sufficient reserves to damp any sort of load loss or load reduction, and as well as on the opposite side of an increase of a load jump to be able to maintain frequency. And so this largely becomes a balancing problem for how do I tell my operator I am going to move my load and that the operator can then be ready. And so we have recommendations on how large loads can ensure their operational readiness, as well as, how transmission owners can ensure the operational readiness of large loads, and that large load owners can obtain that. The next slide, we'll see this automation and UFLS items. When we don't have sufficient reserves in the under-frequency sense, we do have this under-frequency load shedding safety net. So the under-frequency load shedding assessment is done every 5 years as required in PRC 6. The large load time to connection is less than 2 years, and so we can have a significant amount of demand that is increasing within our system, while our under-frequency load shedding schemes are kind of designed or reassessed every 5 years for that system. And so we have in our level 2 alert not only the near-term forecasting needs on that 5th recommendation, but in general, the expectation for off-nominal behavior. So under-frequency load shedding comes into play when we see significant frequency reductions on the system and need additional resources to serve the imbalance. So where an operator is able to procure enough reserves, we don't hit under-frequency load shedding. And when we do, it is a last measure resort to stabilize frequency. And so our level 2 alert identifies areas and processes and procedures for the load interaction under normal and contingency type events, as well as the voltage and frequency performance, so that way these assessments are done in a coherent manner, and that PCs, the entity responsible for producing this, you saw a recommendation for TPs and PCs to establish a study process that identifies the full extent of the reliable impact of these large load integrations, this being one of those studies. On the next slide, please. This is kind of broken into, generalized stability and models. Parts of the load of the level 2 alert identify a need for the load owner or the entity responsible for the large load to supply modeling data so that transmission planners can study their impact. And so you see there an example of the types of load that are within a data center, including the backup generator components. And so we would need models in order to reflect in steady state or transient time domains the impact any loss or change would occur onto the rest of the bulk power system. And so these models are assessed through frequency stability, oscillations, rider, or voltage type stability. And so I'll ask go on to the next slide, as I think that's a little bit more telling as to how these will play out. We can see under fault type events, sometimes a reduction of active power consumption. On the generation side, that is largely associated with momentary cessation of injection of current. We can see something very similar on the large load side, where they will cease the consumption of current as they are moving into their backup generators, and they've changed the source of their power in order to transfer into their backup generators. Now, all of this on disturbance behavior affects the stability of the remaining bulk power system. And so our alert identifies areas where the transmission planners and planning coordinators need to study this, as well as areas to ensure that any stability concerns are fully addressed within every entity's respective environments. And so with that, I want to turn it over to some of the frequently asked questions that we had for our alert. I've kind of given you a taste of where our alert recommendations are, the risks that they're designed to mitigate. And I'll turn it over to Jack to kind of moderate this section. I'll ask the rest of our team to jump on in, come off camera and jump on in to help answer. Over to you, Jack.
All right, thanks, JP. That was a great overview of the alert and very informative. And so I've got some questions to throw at my team here, and some of these questions we assume that there might be some folks that are kind of have these questions in their minds, so we thought we would ask some of these to help everybody here, but also we have received some questions that have been submitted, and so we'll go through those as well and provide some answers, because probably if a few people are asking these kinds of questions, then others are probably have similar ones as well. So first question, it's a pretty easy one, but I'll start out, are there any legal protections to the data that is submitted for this alert? So example of, maybe some concerns that people could have is, let's say you're submitting models that have vendor IP that can't be shared publicly. Any legal protections there?
Yeah, Jack, the section 1500 of our rules of procedure do require any sort of confidential information markings to be adhered to for the data that we receive. And so I would, for folks that are concerned associate with things like vendor IP or other sort of confidential information sharing as requested information from the large load level 2 alert, section 1500 rules do apply for these data submissions. I know that we've also marked that in the data submission sheet that section 1500 rules apply, but that is through all these types of responses. So if you need any other information on that, I would encourage you to review our rules of procedure on our website or send us an email requesting that information.
All right, thanks for that. Next question. Let's say somebody does not have a definition for large loads. What should they do?
Yeah, that is a great question. And I also see that some of the Q&A is about what if we don't have a definition? Well, in the level 2 alert, we included the definition of the LLTF as part of the response. And we generally asked, what is your formal definition of large loads? If not this definition, and give us any example. So that's largely what we ask is we propose the LLTS definition. We'll ask for an entity's specific definition. And so I guess the questions are generally associated with, well, if I don't formally define this load, or I don't define it in terms of megawatts or kilobars or something like that, what do I use? And so we provide, hey, if you don't have a way to relate that to megawatts or kilovolts, we would ask that you provide us loads that are 20 MVA or 20 megawatts and up. That way that we can get a generalized assurance that if there is a large load that would have a megawatt or kV threshold, we're able to identify the total impact based on the responses of this alert. So that's the guidance we provide there in terms of the definition of the load. Again, we're proposing the LLTS definition, and know that that does not have a demand or sorry, a megawatt or a kV threshold. And so if you haven't formally defined it with those thresholds in mind for your area, we would just ask for 20 megawatts and upload to be provided as part of the worksheet.
All right, thanks for that. Okay, so this next one, it's similar to a question we've actually received, and so it'll be kind of specific in numbers, but it's actually a really good question for the group to get an answer to. So let's say you are a relatively small utility, so let's say about 150 megawatts total peak demand. Your largest load is industrial. It's about 50 megawatts in size aggregated. And it has multiple feeds serving that load from multiple different substations. They are 69 kV feeds to that load. And so the complete loss of that load is very unlikely. And lastly, the impact from the loss of that load is very minimal to none for impacts to the bulk power system. And then last note for this load here. So let's say this load it doesn't experience those rapid or large scale demand fluctuations that we may see from other large loads. So given that, hypothetical there, so any guidance on whether such a load falls within the scope of interest under Rule 810. And is this the type of load that NERC is seeking information about in this alert?
Yeah, I think that is a great question, particularly because industry has dealt with sizable industrial scale loads for some time. And we also do see a growth of industrial scale load throughout our LTRA. While the primary risks that were identified by the LLTF were data centers and data centric in that regard, we do ask for loads that have met an operational distinction for risks to the bulk power system to be included. And if that is not a formally defined within your company, we would ask for that 20 megawatt or greater load to be included in the worksheet. So it's going to go down into, based on a bunch of these hypotheticals, if that has been identified within the company as this is not pertaining to risks to the bulk power system because of X, Y, or Z reason, then please share that with us in the alert responses, as we've related that we have this amount of load, yet we've identified that this load does not trip or have the propensity to trip due to X, Y, or Z reason, which could include a historical engagement with this load has shown it to be stable. It does not trip. It does not have rapid demand fluctuations. It's providing to us operational schedules so that way we can plan the rest of our system that is 100 kV and up, even though it is connected to the 69 kV system. Items like that will greatly assist in how NERC can assess the way that these new demands, the data center demands, are integrating with a system that also includes these other types of loads. And so the responses here help us to assess this new entrant, as well as how it's affecting some of the old entrants and the skills and expertise that folks are using from our older scale, very large industrial loads into the newer type loads. Hostler, Evan, would you want to add anything else to that?
Yeah, nothing to add on this end for now.
From me neither.
Thank
All
you,
right.
Jack.
All right. Thanks for that response. Very good response. Very informative. Here's another one for you. So, for the scope of this alert, are we considering only the large loads that are existing or firm? Or are we also looking to collect information on projects, maybe currently being evaluated in the RTO interconnection process, for example? And then the question that we received, some of the further detail they provided, is that some of the future load projects just entered the RTO queue with very limited information available to the transmission owner. So what does someone do in this kind of the situation here?
Yeah, that is a great summary, and I think we went back and forth on exactly when the end date of what we wanted data from, because of those similar types of concerns that newer entrants to the queue likely don't, especially if they're long time from when they enter in their application, if there is a load queue application or when they've requested electric service, they may not know exactly what their facility is going to look like. However, we did need to have some sort of cutoff for projected changes from our current system. And so our data worksheet has an in-service and expected to be in service by X date for in-service by, I believe it's 12. We need to have data for large loads that you are currently having or expected to be integrating by 12/31/2027. And so there's a separate sheet for existing loads and a separate sheet for anticipated loads by that date. And so the worksheet instructions will help separate out the categories of in service and in an operation and expected to be in operation by 12/31/2027.
Perfect. Thanks for that. Okay, I've got one more, probably a pretty easy one, and then we'll dive into a few more technical questions. So this next question is, let's say you do not interconnect generation or load to your transmission facility as you only own HVDC transmission. So you're a transmission owner that only has HVDC transmission. How should that transmission owner fill out the alert?
Absolutely. Thank you, Jack. And this is another good question with some nuance, because we do have and require in NERC standards for transmission owners to have end user facility agreements. Yet in these instances, you are only owning an HVDC line that's connecting 2 points of transmission. That is the entirety of that type of company. And its operational characteristics are point-to-point transmission with a transmission owner on the other side of each of those points. So there is essentially no current way for large loads to integrate within that point-to-point transfer. The hypothetical alternative would be to tapping into that DC bus and making it from rather just a point-to-point to a multi-point or multi-terminal HVDC system. However, those are that is a separate conversation to the practicality of I only own HVDC and transferring point to point. In that regard, you don't have large loads or projecting large loads. The transmission owners of the facilities outside of that point to point transfer would be expected to be filling out a lot more of the large loads. So those HVDC only transmission owners, please make that apparent in your alert submissions that you are an HVDC only transmission owner. As you are not integrating large loads or expect to be integrating large loads, and please answer appropriately for that type of response throughout the alert.
All right, thank you for that. So next few questions, like I said, will be a little bit more specific and technical, getting more into the alert here. So first question here, recommendation 1 points to requirements to minimize and mitigate unintentional power oscillation interactions. Is a large load recommended to integrate active damping into its grid interface?
Yeah, that is a question that we've definitely received, and it's a great question, particularly because active damping can be separated from alternatively separate from injecting oscillatory behavior. So our recommendation largely says for known oscillation modes, do not inject or cause injections of current or consumption of current in an oscillatory manner that is similar to those modes. And so those could be like the 0.25 hertz mode in the east. So that relates to a certain time constant of certain controls. And those time constants should be avoided for these data center facilities due to the known participation in that type of mode throughout the system. That is where our recommendation has largely settled. Installation of active power oscillation damping equipment can be extremely helpful for these types of solutions and to enhance the damping of known oscillatory modes. Yet that also needs to be done in consultation with your transmission planner and integrated appropriately with the right operating entities. So our recommendation doesn't say to go install power oscillation dampers, but it does basically say don't inject or inject an oscillation or operate in an oscillatory manner that is exciting known modes or causing local damage for subsequent or subsynchronous oscillations. So I'll turn it over to Hasla if you want to add a little bit more to that.
Thank you, JP. Yes, so based on some of the work that was done on the white paper one, you would probably have seen, if you read it, some of the waves, right? So it is a forced oscillation. It's nothing that's inherent to the physics of the system. It is more on how the energy is used. So there is a periodicity related to how you use it, and this is very very specific to these new emerging loads that have a common workload, like training a big AI model and then the work happens in a certain periodic manner, which results in forced oscillations, like JP shared. And I think in this recommendation, we just want the TO to work with the TP and PC to be aware of where the risks are, what should not be, what should not be added from the emerging load, the large load into your system. There are areas that they need to they should not operate, and making sure that they are aware of this, and so that you don't excite any underdamped modes with these forced oscillations from the data center demand. Thank you, JP.
Perfect. Thanks, Asla. Thanks, JP. Okay, next question for you is recommendation 2 points to coordinating the protection studies with the large load entities. Does that mean the transmission protection setting have to be changed? How can this be implemented in practice?
So I think that I'll rely a little bit more on Hasla to fill in some of the details, but we've seen that a coordination of transmission protection does not require the transmission owner to now change their protection philosophy to account for the needed protection of large loads. Rather, this coordination effort ensures that the transmission owner, in pursuing the protection of their own system, ensures and can help coordinate with how the large load is going to participate. Since we saw in some of the Dominion events that and the subsequent results from Dominion speaking with their large load customers, that they were able to resolve a lot of the trip outs for multiple minutes by coordinating the protection settings within the facility. And so that's where this recommendation takes its heart in, is having the transmission owner and the large load identify and coordinate how they can they protect their facilities to ensure that minimal degradation of the BPS is achieved. Over to you, Hasla.
Thank you, JP. Yes, so at the end, when it comes to protecting the system, the electrons, they don't care who owns the asset, right? It could be on the data center side, it could be on the TO side, but I think so that's where we I think that this recommendation is about making sure you the TO working with the data center or the large load to ensure that if there is a fault somewhere in the grid, that you have the minimum misoperation. And for large loads, this is where it becomes different from traditional protection, because they do have these large loads. They have a backup. They don't need to rely on the most of them. Quite a few of them have a backup, so they don't necessarily always have to rely on the grid power. So they can decide when they want to get off the grid. And so these decisions are typically control signals, control logic, and they might not be captured in the typical 20-second transient stability simulations that we carry out. So being aware of that and considering that in the planning stage, in the interconnection stage, would help ensuring that we minimize the misoperations that we probably saw in for example in the incident review from the Northern Virginia event, and I think we had like 3 or 4 events like that in the same area. So that will help have a better reliability for when you have disturbances on the grid. All right, what you, Jack?
Perfect. Thank you very much for that. Okay, back to recommendation 1. Recommendation 1 points to high-speed disturbance data capture devices. What are the ideal characteristics of those devices?
Yeah, and I think that's where we see a lot of how fast and how often are we going to be needing to trigger these items. So PRC 2 does demonstrate a few high-speed capture limitations, associated with the data recorders themselves. And so we would see a sample rate associated with a high-speed data retention to be anywhere in the tens to hundreds of samples per cycle. And we would expect those fault recorders to exist or to only capture data when the high speed nature of that is warranted. So outside predefined trigger bands. So those trigger bands need to be set on the local system conditions. So a voltage hits below a known fault. So 0.77 per unit for a 3-phase system can capture quite a bit of single line to ground to 3-phase faults. However, if all we're concerned about is a 3-phase fault and we're just triggering off of a positive sequence voltage, we would need, or we could reduce that down further as close-in 3-phase faults, where this facility is likely to participate and affect the way that the rest of the system recovers from such a fault. That trigger can be set much lower and only identify those specific events. So when we deal with fault recording devices, we do want a high sample rate trigger-based method. Now, there's also high fidelity transmission of this via PMUs or other measurement devices to an operator's SCADA EMS system. And so those could be more routine polls that are not as granular or require as much or as high of a sample rate. So those can be at a much reduced samples per cycle, maybe 2 or 4, to catch each zero crossing or each peak in amplitude for those types of measurements. And so there's a wide variety of products available. And so our generalized recommendation is to choose a high fidelity, high sample rate disturbance recorder for known disturbances and trigger those disturbances to share with the utility, as well as provide a good way to coordinate with your operating entity in that lower sample rate type manner and generally be operational ready.
Perfect. Thank you for that. Okay, on to a easier question here. Pretty simple, but it will be very good for folks to know. It's how do we submit the data center models? Do we need to submit only EMT models? Do we need to submit positive sequence phasor domain models?
Yeah, that's a great question too. So we ask in the alert for a zip archive of all of the models that are associated with the loads that are submitted in the worksheet. So for some, that can be a generalized component model that's associated with all of the positive sequence models in a proprietary software domain. So that could be a .dyd, for example, if you're using PSLF software, or a .dyre file for PSSC software. So all we're asking for is a zip archive of the model used in your simulations, in operations and planning. So if there is a EMT model and a positive sequence phasor domain model, we would ask and request that the zip archive contain both of those models for the facility. So we're essentially asking for what, in that zip archive, the model that is used to represent the facilities that are listed within the workbook. So that can take many different forms, and all we are asking for is not to be overly, it's not designed to be overly burdensome. We just want to know exactly what the model that is being used. So if that at this point is just a .idv in PSSE that changes certain parameters and is an automation script associated with it, sure, that can be your model file for the facilities that are listed within the worksheet. We largely need to just assess the state of modeling for these facilities. And so any model that is high fidelity, we'd love to see and look at, so that way we can see some of these components. However, if it is just a PSPD or positive sequence phasor domain model that is using, as some have also recommended this year, the aggregated EV model to represent a data center, we would like to see that model in there as well for each of these facilities. So that zip archive is designed to contain multiple different domains or types of models, and we would just ask that you build your zip archive in a way that makes it clear and attributable with that load ID that we ask for in the worksheet, so that way we can attribute the model to the respective loads.
All right, thank you for that. Last question for you that I have is, so if you're a registered entity and you need help navigating the system, uploading a file, or anything else, how can one reach out to us to get some help with that?
Yeah, that's a great question. And so as part of the alert, there's 2 emails. And it can be a little confusing as to, if I have a question, who do I submit it to? Well, there's we categorize it into kind of like that administrative, or if I need help in submitting a file or help with the system and how we're sending this information back. So largely the login account, issues with the portal, issues with the system, email nerc.alert@nerc.net. That's on the bottom of the level 2 alert. If you have clarification or content related questions, email engineering@nerc.net, and you'll get the panel here, as well as a few of our other engineers to help answer your question. So if you have trouble with the system, trouble with zipping up and adding files, email nerc.alert@nerc.net.
Perfect. All right, thank you very much. That's all the questions that I had for you on my end. All
right. So I'll ask the rest of folks to come off camera. And so I'll take a little bit of the WebEx Q&As here and generally ask Evan, Jack, or Hasla to give their thoughts and generally answer the audience Q&A. So we did have quite a few questions on, is the large load definition required to be categorized in megawatts or have a kV threshold, or what is the definition of large loads alerts? We've answered that verbally prior with the the FAQ there. I want to ask, maybe not necessarily related to the alert, but just generally how the conversations about demand thresholds have occurred in the LLTF. Jack and Evan are the coordinators for that team, so I'll ask Evan first to kind of share how the LLTF approached set demand or KV thresholds, and ask Jack to also weigh in.
Yeah, thanks, JP. So this was a really big consideration in the writing of the first white paper, is creating a definition for large loads. So we initially did a survey to figure out if people could pick their own threshold. What would that threshold be? And this was just considering megawatts. Most people picked a value around 50 or 75. And so I think that gives people a good idea of where a lot of entities are currently using a number for their internal processes and different types of studies. Now, I think another really big consideration was the KV that they're connected at, and whether they actually connect directly to the bulk electric system or to the transmission system compared to the distribution system. So I know that's a really big consideration as far as whether people need to treat the load differently in terms of studies or process or other things. Some of the other considerations that we looked at in the paper, as far as what kinds of criteria you might use in order to differentiate one load versus another that maybe needs more study or different processes, as I mentioned. Some of these characteristics could include voltage sensitivity, the types of price signals or other signals that they may respond to. Definitely ramping behavior is something that was something that could increase the amount of risk. And so I think a lot of these different attributes of the load operational behavior, as well as things that go into how it responds to disturbances and other situations on the grid, that all of these combined can really help you decipher the amount of risk from each specific load, and like I said, whether it needs to go through specific processes or studies. So these were a lot of the things that we looked at in the white paper, and we recommended that some of these can be different for a region or even individual utilities, or things as big as the full interconnection that the load resides in. So all of these things together are things that we recommended to be considered as far as any regulations, standards, or registration efforts in the future.
Jack, anything else to add to that?
No, that's very well said. And I think the only thing I would add to it is just, we've had large loads on the system for a long time. And so, but I think the key thing to be looking at here is, as Evan alluded to, not just the size, but the performance, like how that, maybe even what the demand of that load looks like, right? And so a small load that, fluctuates in demand rapidly, maybe even has a demand that looks like an oscillation. It could present a different or more risk to the system than maybe a larger load that is pretty stable and not as voltage sensitive, things like that. And so there's different aspects, but really just repeating what Evan provided.
Absolutely. Thank you both. We also received a question that was asking essentially what is formal when we ask for the formal definition of loads and how it is applied. So if an entity has a large load definitions to calculate tariffs or rates, is that the definition that our alert is seeking? These tariff definitions are not used for operations or planning decisions. It's purely rate calculations. We are unsure if this is the info for what NERC is looking for in the alert response. I want to first start off in saying I think that if we can easily separate a tariff definition from an ops planning definition, let's go with the ops and planning definition. Our goal of this alert is to assess the operations and planning of the bulk power system. And so if that tariff definition does not make its way over into interconnection processes, facilities, studies, or any sort of operational concern, it's largely not defined in the scope of what we would look for, and we would ask for the formal definition that's used by ops and planning teams. Hasala, would you want to add anything else to that?
No, JP, I think you covered it really well.
Perfect. We also got a question here, and I think there's another one later on this sheet about under frequency load shedding. So I'm going to try to combine a few of these here. So we have a question of, is there a plan to identify how to properly balance under frequency load shedding load, much smaller, compared to large loads that may not be required to have UFLS schemes? We also had a question on UFLS about, for question number 3A for all TOs and DPs. Sorry, never mind. That's not the right one. Sorry, there it is. To comply with PRC 6, can a transmission owner or planning coordinator require modular large loads to participate in UFLS blocks? So those two are largely our current UFLS questions that we'd have. And so I'll give a quick overview of PRC 6 to start with, and then I'll throw it over to Evan and Jack. So PRC 6 is the design-based standard for under-frequency load shedding schemes. The planning coordinator needs to design a scheme such that the interconnection frequency returns in an imbalance of load and generation of up to 25% in known and identified islands. Now, the planning coordinator then shares that scheme with transmission owners, distribution providers, and distribution providers that are only registered for under-frequency load shedding schemes. Those entities are responsible for finding and selecting the amount of load and what kinds of load to arm in their unit under-frequency load shedding relays to meet the planning coordinator's overall targets for the under-frequency load shedding schemes. So there's a little bit of nuance there of who requires what in the large load, but the clarity of the planning coordinator is responsible for the holistic design and target thresholds of load shed to arrest significant under frequency sheds, and the implementing entities that are going to arm the relays are transmission owners, distribution providers, and distribution providers that are registered only for UFLS. Jack, would you want to add a little bit more to that?
Yeah, this is an interesting concept we've been talking about in the Large Loads Task Force and basically there could be a need, especially if you're in an area that has lots of large loads of significant size connecting to your system. There could be a need to start looking at the large loads and maybe incorporating them into the UFLS program. That could be the case, just depending on your situation, right? But one thing that is probably a little bit concerning is, let's say, for example, you have maybe 1,000 megawatt large load. Putting that on one UFLS relay or a setup that would operate to open that entire thing at once may not be one. Obviously, that's not ideal for the large load, but that's kind of the situation. It's an emergency situation that you're dealing with. But on the other side as well, though, that is a very, very large amount of load to drop at one time. And so there could be some concerns there. And so that's where we've talked about, well, maybe there's a place for being able to drop a small amount of that load at once and things like that. And then there's the kind of conversations of like, okay, so who owns that relay and how does that all work? So all things that we've been thinking about, but I do agree though that there could be, depending on your situation, you might need to look at these loads and look at incorporating them onto your UFLS program, because to make sure that your UFLS program is adequate, moving forward. But also there could be a need to make sure that you can shed that load modularly or a small piece of it. So that's something we've been looking at. I assume that utilities are kind of thinking through their UFLS programs and reevaluating them as the grid is changing very rapidly. But that's just kind of a little bit of flavor of some of the conversations and things we've been brainstorming in the LLTF.
Thanks, Jack. And if I could, again, I guess summarize back to the requirement side of things. Our current standards would not require large loads to be part of or armed on a UFLS relay. Those are decisions by our registered entities that would need to work. And there's potential for like benefits here for modularization of the load that can assist in underfrequency load shedding schemes. So I think that our alert recommendation is to be ready and to have large loads be ready for these types of calls, particularly because of the sheer demand that some of the larger ones are able to hold. And so should those become islanded, they are a significant portion of the islanded demand. And it is highly likely that part of the performance of that island will be related to the potential of that facility to shed some of its load. Again, UFLS has many different priorities for the loads, and priorities that are things like hospitals or centers that do need electrical service during emergency scenarios. Those are largely prioritized above some of the items in underfrequency load shedding schemes. And so each utility makes that risk-based decision per our standards there. Evan, anything else you want to add?
Yeah, I'll just add that, I think this is related mostly to question 71 around asking, do you guys include large loads in your UFLS or UVLS? And I just want to highlight that also in the LLTF papers, White Paper 1, we've got some sections about the considerations and risks related to UFLS and UVLS as well. Of course, in White Paper 2, we talk about the gaps potentially in those processes. And additionally, in the draft reliability guideline, there's a lot of guidance around, who might be responsible and for what in regards to coordinating with your planning coordinator to see if UFLS on large loads is something that is the right decision for you, your utility, and your planning area. So, just wanted to highlight that there's you can find in each of the papers some guidance around this topic.
Perfect. Thank you, Evan. Thank you, Jack. Hasla, do you want to add anything else, or shall we move on to another question?
Yeah, let's move on, JP. Yeah.
Perfect. There's still questions coming on in, so please be sure that if you have a question, please enter it. We'll try to get through all these questions here. We have a question that states, are there any large loads considering coming online completely off-grid? So that is essentially operating in an islanded nature from the bulk power system. Hasla, I'll turn it over to you to start with that.
Yeah, thank you, JP. Yes, so what we have not seen this as a trend, but we have heard about scenarios where when they cannot get the full capacity they have put on big gas turbines on their site to be able to get power, but to the capacity they need. But it does not look like that it's going to be a trend. So that's what we see right now.
Perfect. Thanks, Hasla. Evan or Jack, do you want to add anything else?
Yeah, I'll just add some of the sentiment I've heard, at least from one entity that's more on the data center side, is that the islanded situation does not seem to be one that they desire. They would rather be grid connected, is kind of the sentiment that I've heard.
Perfect. Thanks all. And I guess I want to underscore in those responses, when it is in a islanded non-parallel operation with the bulk power system, the impacts to a entity's facility only occur when we're operating in parallel. There's a solid connection from consumption device or source device to consumption device electrically. And so if there's electrical isolation, when it comes to our alert, that initial connection would occur if at a subsequent future date that data center decided to build an additional grid connection to the island, similar to how we see some microgrids establishing a utility connection after they've operated in an islanded mode for a significant period of time. So that's where our alert would come into play, of asking for entities for that procedure when they're seeking the utility connection, not for building their own isolated grid. So there's another question here on modeling software that has been used for transient study with the item of EMT. I think that it's good to identify what we mean by transient dynamics. The majority of transmission planning operations deal in positive sequence phasor domain to current date. However, some EMT studies are currently being done to evaluate certain aspects of performance. And so when we discuss transient dynamics, we're largely focusing on the positive sequence phasor domain, though EMT analysis could be considered. So I'll turn it over to my fellow panelists here to kind of give a little bit of information, but I'll say when we say transient study, we're not talking steady state EMT versus transient EMT. We're largely talking when we deal with Newton-Raphson load flow or steady state studies into ODE solved transient domain simulations, typically now in positive sequence phasor domain. Anything else from Evan, Jack, or Hasla?
I can only add that, we don't have a preference on what tool you use, but, that you do a state-of-the-art, use a state-of-the-art tool to do the study. And yeah, so transient, for EMT, you might not always need to do EMT. It might be based on a requirement that you need to meet.
Perfect. Thanks all. Evan, Jack, anything else to add?
No.
All right.
No, nothing for me.
So we got another question about the data center load dynamics being different from traditional large loads. It reads that data center dynamics can also cause concerning issues, even at smaller load values that may not qualify as a large load. Wouldn't it be better to focus attention on data centers rather than large loads in general? So I'll turn it over to maybe Evan first, and then see if another panelist wants to help with that.
Yeah, that's definitely something that I think we talked about a lot in the first white paper, is that independent of the size, that some of the characteristics on their own might present challenges to grid reliability. So, we definitely are looking at data centers, I think a little more closely than some of the other load types. And I think you can kind of observe that in most of the paper, is that I think the highest, or I guess I'll call it the greatest impact risks, are a lot of the things identified as characteristics from data centers, but that I think we're really trying to focus more on of any load. If it has this characteristic, that this brings a certain set of risks. So we especially on that first white paper, we wanted to be inclusive of all types of large loads, so that we didn't want to miss anything, and that we could accurately capture what is all the risk from the class of loads, large loads. And of course, we are working on actively refining this in our ongoing work, of course, with the reliability guideline, and eventual work in anything related to standards, that we will certainly focus our attention towards where the risk lies, rather than just addressing something from kind of a umbrella point of view, or blanket kind of point of view.
Absolutely. Hasla, would you want to add something?
Yes, a quick add-on to what Evan shared, is that that's what we want to get that information from you, so that we can make a determination, and if we have the data, we will be able to of all the large loads, we'll be able to place data. We'll be able to get more granular as we move forward. So that's why it's so important for you guys to provide us this information as detailed as possible, talking to your large loads, so please do help us with getting this information, and we agree that we need to be granular, and then that is our intention. Yeah, looking forward to analyzing the data and getting more granular as we move forward.
Perfect. Thank you all. We have another question that states essentially, what about the webinar slides to be posted? And generally, I want to remind participants that this webinar is recorded. We'll be posting a recording of this webinar. We can include the slide deck associated with that posting as well. Information on that posting and where it's finally located on the NERC webpage will be shared with you all at a later time. The other question we have came up for large loads. Are we reporting only on those connected to bulk electric system facilities? We have 2 larger loads that are connected to 69 kV. Are we expected to factor these into our response? So I just want to come back to, in our sample worksheet, we provide some sample data. And we tried to envision this response of, I have a sizable load, but it's connected to a lower voltage level. And so we placed a sample, a fictitious example of a 20 megawatt data center load connected to primary distribution voltage for 34.5 kV as part of the sample data that we were generally expecting for the 20 megawatt threshold to work into. So we allow for a numeric entry for the connecting kV. And so we would be interested, and I would want to have my other fellow panelists also chime in, on those larger loads that are also connected to lower kV classes, as that helps us define any sort of voltage boundaries that may exist already in the system. Evan, I see you nodding quite a bit, so I'll turn it over to you.
Yeah, certainly. I think the emphasis here is on if it applies to the definition of large load, that we definitely want to hear about it. And if I could say, I would lean more towards including things that maybe you're unsure of, especially if you're calling it, in your message, maybe a larger load for your system. And so we definitely want things that might be under the kV threshold that maybe you would typically consider. So 69 kV, or I see in the example spreadsheet one as low as 33 kV. So definitely these are the types of things that we want some more information around, as that helps us to, as JP said, kind of figure out where we want to draw the line in the future. So that's all I have to add.
Perfect, thanks. Jack or Hasla, anything else to add?
Nothing from me. Well said.
Perfect. There's a few questions that I'm going to kind of combine by one submitter that occurred, and my apologies if we wanted to change some of this into separate questions, but the request is, will the large loads be considered or have to be considered as a transmission component or not? And how can the risk be identified in the first place without running those types of studies? And so I kind of want to do a dual answer to those questions. In transmission planning environments, we typically have 3 different components. We'll have a generation or a resource component, a transmission component, and an end-use consumption component. So loads, being end-use consumption components, would fall under that type of category. And there's different tables associated with that in planning software. I wouldn't want to extend that any further into a broader, it will always be considered not a transmission component. But I think that a lot of the transmission facilities to serve large loads may reach transmission status or transmission level KVs, depending upon the size and scale of data centers, as we do see some that are significant, like the gigawatt hyperscalers, for example. Any other response for folks on the panel?
No, JP, none from me. I think that was a good response.
Yeah, so we see connected at say 350 kV and above for some of these very large 1 gigawatt or 2 gigawatt size. That's what I understood, that we have that large data centers coming in. So they will naturally be connected at a very high voltage level.
Actually, I said I didn't have a response, but let's think about how can the risk be identified without running the studies? I will, to that's a great question. There's actually been a lot of folks throughout the industry running studies on large loads and their system, looking into the risks from the large loads. NERC has ran some studies, and there's been presentations kind of throughout the industry on some of these studies have been done. So I would encourage you, you'll see some of those presentations in the Large Loads Task Force venue or other venues throughout the industry. But yeah, there's still a lot of work going into this throughout the industry to learn more and more about the risk, but a lot of work already being done.
Absolutely. So we'll move on to our next question, which broadly asks, are distribution providers expected to have dynamic models for data centers? And if yes, then what is the purpose? I wanted to kind of overview two things. One is that the way that we view a distribution provider is essentially the one that owns like that last little bit and maintains it for the end use customer and provides some sort of distribution. In our registration criteria, the transmission owner can be a distribution provider in certain circumstances for where the end use customer is interconnected at the transmission level. In our registration criteria, that says that in these instances, the transmission owner is the distribution provider for that entity. So there's a little bit of nuance there when we just say broadly, are distribution providers expected to have dynamic models for DCs? Generally would say if you do have one, we want to see it as part of this alert response so that we can assess the current nature of where things are. And we'll then be able to correlate the distribution providers that are at the transmission service level, because we do not bound the KV of the distribution service level, and those that are at typical primary distribution levels that would be much less. And Mod 32, my second point, would require that the distribution providers work with their transmission owners to reflect models of their facilities to the transmission level. And so the distribution provider may not own or use their model, but they do have a role in making sure that the equipment connected through their system is represented in the transmission owner's submission to the transmission planner for their models. Hasala, would you want to add a little bit more to that?
Yeah, so here, if so if you have the models, we will be able to, if you have it and you submit it, then we can get an idea of what's the parameters and the commonalities across the board, and I think that will help us kind of understand the associated risk from starting from distributed provider connected data centers or large loads versus the TO connected large loads. So if you do have it, please do share it with us. It will be of use to us as we create strategy moving forward.
Perfect. Thank you, Hasala. Evan or Jack, anything else on that? All right.
Nothing to add for me.
Perfect. We have a question for, and I think Hasala, you wanted to take this one in particular. So the question reads: the load loss following a momentary disturbance might be a normal, not a misoperation of the data center power backup design. Backup generators are started at the first sign of trouble to ensure carryover of the UPS batteries, and once the generators are started, there is a commitment to transfer. And that commitment to transfer allows the generator to exercise to avoid mechanical issues such as wet stacking and the like. Hasala, would you want to take the lead on that?
Perfect. Thank you, JP. Yes. So here, I think the most important information we need to know is how the data center or the load would respond to moment of disturbance. And so understanding what those characteristics are, that would be very helpful. If when we do the studies, we would know how your system will respond. So And we do agree that wet stacking is a problem. So you once you start the so the first decision point here is what the data center will have is whether to stay connected or disconnect, and so there would potentially be space. Is there? So I think the first question here we need to consider as we move forward is there any space to change these parameters such that it helps the reliable operation of the grid? So so that's one piece. And the second piece is that we need to make sure that the data center can, once they get into the backup diesel generator operation, that they come into the grid in a way that also supports a reliable operation here. So but again, the security of the facility is paramount. But if we know how these data centers operate, what the logic is, what their flexibilities are, then that would allow us to look at solutions that will enhance the grid reliability. So but we do recognize that there are operational constraints that come with a data center.
Perfect. Thank you so much, Hasla. And I guess I want to underscore that while I didn't state it specifically when we reviewed some of the content of the alert, we are working with UPS manufacturers and other manufacturers to really ascertain the parameters and settings that Hasla has demonstrated. So we do work with like agencies under NEMA and certain groups in NEMA to really understand the manufacturing, the design, and the needs on those uses, and trying to be able to identify areas on if items can be changed to help support the reliable operation of the power system. So it's a great question, and it's definitely one that excuse me, will take a little bit more in terms of marrying the electrical needs with the mechanical needs, as we do understand that once that commitment to transfer has been established, there are mechanical reasons why that has to go through. So the next question that we have here is, we had one that said, the question for number 3A for all TOs and DPs reads, if the answer is yes, enter the data as indicated in the supporting worksheet. Also, attach the .zip archive with all the large load positive sequence phasor domain models included. See additional submittal information at the bottom of the section of this alert. Provide at minimum the loads that meet the formal definition in question 1. And the question is, what type of model files are you looking for, that dynamic, IDV, or other? And we answered a little bit of that before. We are asking for positive sequence phasor domain, but we're largely trying to understand what the model that is used to study in planning and operations for this data center. So some of those other file formats are or workable within the zip archive. And again, we just ask that you structure the zip archive in an identifiable way to what's entered into the workbook and the worksheet. Anything else on that, Evan?
No, I think you stated it really well. Any organization you can put into the folder that you submit will, of course, certainly help us in, like JP said, lining it up with the records in the worksheet. So.
Awesome. Our next question is related to that workbook itself. It was, is there an unprotected version of the workbook available? Some needs to be completed by the large load, some by the TO. And we do envision that that coordination to exist. And so that's a great question, because it's we do envision that there is some coordination between the TO and the large load customer. That said, I don't believe that we're generally sending around unprotected workbooks for this, for the alert, primarily for making sure that we can gather and assess the data in a systematic manner. However, we would encourage you all to reach out if you do have a need for an unprotected workbook or the like, to work with us directly. So send us an email at the DL list here, engineering@nerc.net. and we can try and help work through some of those issues. We'd be more than happy to assist to make sure that that works. In general, though, we wouldn't be posting an unprotected workbook as we've done so in the past, and that has significantly hampered our obligations related to alerts that are also in our rules of procedure. The next question reads, would NERC consider an extension for the NERC alert questionnaire due date? A majority of the questions are transmission planning related, and the end of year period is incredibly busy for planners as they need to complete the annual planning assessment for our TSP, and this crunch is the case for many other TSPs as well. To ensure a complete and thorough set of responses, a due date in the late winter or mid-spring timeframe would be beneficial for all involved. So I'll also start this question and maybe have Jack fill in afterwards. We did discuss what date would be generally acceptable for the length of questions and the generalized response rate that we would receive from all of our entities. We understood that should there become crunch times and the inability to access this data and get a complete picture, an extension could be considered as we reach that date. At this time, we're not going to commit to an exemption or extension at this time. However, we'll be looking at response rates as they come in near the year end and in the beginning of January to see if an extension is warranted for those same considerations. Jack, do you want to add anything else to that?
Yeah, sure, for sure. Yeah, definitely understanding of the end of year crunch time and one thing on this issue, it's a very fast moving issue. And so as soon as NERC's able to get the data collected, we'll be able to start looking through the data and getting an even better understanding of really the lay of the land, what the risk is in this area. We've got a pretty good understanding, but this is going to help out a lot as far as how to address these risks and things like that. And so it's very fast moving kind of environment, really. If you look at load forecasts, they're all skyrocketing. Even if the delta between the high and low forecast is large, regardless, any forecast you look at, it's skyrocketing very quickly. And so a lot of these large loads can connect very quickly to the system. And so I think the industry is really in need of, of the next steps of how to get the risk addressed. And so the sooner we're able to get that data, then the sooner we're able to kind of continue moving forward and understanding and identifying what some of the good mitigations are in this area. So that's all I've got.
Perfect. Thank you all. I've been going in time order for a while now, and I'm seeing some pop up for commissioning. So I'm gonna try to tie all the commissioning questions together here. So recommendation 3 is our recommendation for commissioning. And so regarding that and questions related to that recommendation, is the recommendation to have field commissioning confirm at energization the different model parameters for these data centers or large loads, or is the intention to have metering or have the customer provide data information back to the utility to confirm the original modeling information that was provided? And further, we had another question related to commissioning is, what does NERC consider to be included as part of the large load commissioning process associated here? I'll turn it over to Hasla first, and then maybe Evan or Jack to follow up after that.
Thank you, JP. Yes, so I think here's the challenge, right? So for loads, we do, the commissioning part of it is not as clear as say a generator. So making sure that there are procedures in place and that any changes that are done are recorded, and making sure that we elevate that activity so that we can get the models, get the representative models and in changes into the submission, that's going to be very helpful. So I think that's where we kind of shared a few things you could do to enhance that process so that you all can get correct, realistic, representative data, because things change, right? Especially in the data center world, maybe you buy a facility, the owner buys a facility, they're not sure what to put in, and then maybe they provide that facility to some entity who will put in some racks, but they might be not, not have finalized what kind of, hardware they're going to put. Maybe it's a cryptocurrency mining facility. It could have different hardware to maybe AI training facility, and then maybe you have a co-location, where you have a facility that's being used by different end users buying the time. And so, so all these different use cases could result in significant changes, starting from your interconnection agreement to your commissioning and then energization. So, making sure you track those changes and provide that input, and you get that input into the TO processes will be very, very useful in getting, when we model it and when we use it for planning studies, we would ideally like to have more realistic information in the models and with the operators. That's all I had on that, JP.
Thank you, Hasla. And I think that that's generally where we would view our commissioning practices. And we can kind of take some lessons learned from our generation counterparts here, where a lot of the facilities that we would seek as a field commissioning test that confirms that the equipment that was procured to the interconnection application meets what was studied. And so there's ongoing conversation as to if there's differences between what's commissioned versus what was studied, who changes. But I think the process really helps set those priorities. But largely we want to see to establish a process where we do have some field commissioning, where a series of tests are established for the procured equipment on energization, where we start beginning these tests and getting ready for the full turnover back to a commercial operation date. And that information is shared back into your planners and operators for modeling updates and any sort of changes to equipment that then they can evaluate for any other reliability impacts that such changes may have occurred throughout the construction process. Evan, do you want to add a little bit more to that?
No, I think you hit the nail on the head there. Anything that happens after the initial study all the way up to that moment where you energize it. I think all of those processes that you mentioned are exactly what we're looking for.
Perfect. So the next question has kind of with it a term called sympathetic load loss. So the question is there importance of the size of the load? And the kind of other text is sympathetic load loss can add up under contingency conditions. And so typically how NERC has approached these types of load reductions, and TPL1 has some language associated with it, is the difference between consequential load loss in order to isolate the fault or other system disturbance that is posing a risk to the system. That consequential load loss is known to be lost due to the protection action to isolate a fault or other system disturbance. The non-consequential load loss occurs when the entity outside of that boundary is tripped based on the system performance. Now there's that other category of there is something going on in the system. I can still maintain my consumption of this based on what's going on in the system, but I'm going to do something else and initiate a reduction based on either control algorithm or some other manual or automatic scheme. So the size of loss versus the size of the total load is definitely important. And I guess I want to focus in on the size of the interconnection application is definitely important. And in my mind, a little bit more important for our level 2 alert, because we're focused on interconnection, commissioning, study, and operations. Now, it is still important for when we deal with load loss and post-disturbance recovery and fault analysis to have the necessary information as to the loads doing something and how that is related to the system performance. But I think the sympathetic load loss, while it can be sizable, is one of those that like the size of the total amount at risk outweighs the potential for it kind of gives that upper limit to say. So the customer initiated load reductions is capped at the total amount of at risk of doing that operation under faults or disturbance conditions. So that's where I would kind of answer that question of like, is there importance to the size of the load based on the context here? Jack, would you want to add a little bit extra?
No, nothing from my end on that one.
Evan or Hasla?
Nothing from me either.
Yeah, just one maybe detail I can add. We had a great presentation from Dominion and the Large Loads Task Force, and you can find that presentation on our website. And they did mention from that 1500 megawatt event, the average load lost was about 70 megawatts, I'm pretty sure. But we also had loads as small as 2, 3, 4, 5 megawatts. So, we definitely are looking at the aggregate impact of all the large loads in a given area that may have that really big impact, as you mentioned. So all of those things, I think, if they have that strong impact to BPS reliability, that those are things that we're interested in. So that's all I've got to add. Thanks.
Perfect. Thanks all. Our next question is related to the October 23rd DOE letter to FERC for large loads. That is, how will this order impact the next steps for using the data from this NERC alert? It says the DOE order clearly defines the large load threshold as 20 megawatts. And so we've actually reviewed this letter, and it's, I think, 12 points of process that the DOE identifies to FERC. The alert schedule and the alert data, it largely is designed for our rules of procedure section 800, I think it's 810, is the entirety of what we require to assess the ongoing conditions of the bulk power system. And so the data will be used in its express purpose. We want to assess how entities are interconnecting loads and generally formally defining loads. It may be useful to help substantiate some of the claims within the DOE order itself, should we start seeing a lot of loads show up at 20 megawatts, or that the formal definitions of operations and planning, as seen by our registered entities, include loads of 20 megawatts or greater. So I would generally answer that the DOE letter to FERC largely, it doesn't impact like the timing, as that letter does have a FERC expected reply somewhere in the April, I can't remember the date, the April timeframe is when I believe they expected FERC to reply. However, that does not really impact the way that we're going to analyze and assess the data and generally use and enhance our processes, procedures, and the like for the reliable operation of the bulk power system. Hasla, would you want to add a little bit extra to that?
Sure, JP. Yes, so here I think the only thing I would like to add is that the kind of the numbers out there are recommendations or suggestions. There were no strong numbers presented, but I think that this is where the data you share with us becomes so important. So I'm hoping that we would not need to look at or think about any extensions to the deadline. But what we can promise is that, if you have any questions, please send it to us. We'll answer you as soon as possible, and then make sure that you guys are supported to be able to submit the information to us by the deadline. So, and this will be very valuable, for the intended purpose, as well as perhaps to support some of these other things that are going on right now, like the DOE letter order to FERC.
Perfect. Thanks, Hasla. So the next question we have here is, has the LTF had any discussion about large data center customers potentially having their own frequency ride-through settings and how that might be coordinated with UFLS? I'll turn it over to Jack to start us off.
Yeah. in general, and there's been so many conversations in the LLTF, so it's hard to keep track of what exactly we've looked at specifically. But we have discussed some of this coordination between, UFLS or UVLS, one or the other, but I think both apply in this answer. And then what the ride through, or I would say even, you could replace that with protection settings are or whatnot within that data center. That's very important, in my opinion, to be looking at and coordinating with the data centers on, and other large loads, because if you have UFLS, that's going to operate at a certain frequency, but then you also have maybe some very large loads out there that may be operating at a similar frequency, like there's, or maybe above or below that, like that kind of coordination probably needs to be occurring. Same thing on the under voltage load shedding type of stuff as well. One concept that we do talk about in the draft second paper is, if you're requiring these large loads to ride through a fault or whatnot, then there could be, some concerns about, especially if you're looking at having a constant, I always forget this, constant power or whatnot. Basically, depending on how they're set up as far as what they might look like during that disturbance, then you may need to be thinking about your UVLS schemes in the area as well. So there's just all that kind of protection right through all those kinds of things that you need to be, probably considering, in my opinion, because there could be some, interactions between that stuff. So.
Perfect. Thanks, Jack. Evan, do you want to add a little bit more to that for the LTF conversations?
No, I think that what Jack said is right on, and that the coordination really there is the key.
Perfect. I guess I'll only add a little bit more on the UFLS design. There are certain requirements to model generation protection settings that may trip the generator between a frequency that's wider than the frequency that's the simulation is designed to be within. And I could easily see how some planning coordinators would need to reflect that back to load that is also tripping during this time for the over frequency section of any study that is looking at frequency excursions. We have a question here about how to respond when another entity does the function that's described in the recommended alert. So how should entities respond when another party performs a function described in the questions directed at their function? For example, resource planners may coordinate with others who perform the actions described in the question. I'll turn it on over to Evan to see if you would want to start with that. I might add a little bit more context and open up to the rest of the panel.
Yeah, and I think that we did envision there would be some situations like this when we created that questionnaire. I think that as much detail as you can give us around, hey, this specific function, someone else performs that for us, all of that is going to be really useful insight for us to figure out where the risk lies in this area. So I think that's the main thing I wanted to say, is that if you can provide us detail around where things are not performed by your entity, but that they are performed by someone else, then all those details would be really helpful for us.
Absolutely. And I think that further, if you as the entity are performing a function that, say for instance, as an RP, but there's a question that you could potentially help answer in another portion of the alert that's not assigned to you, we'd love to have that information. The more information that we have, the better our analysis can be for this type of data. So we definitely want to hear the process. We want to hear the entities that are coordinating to make this a reality. And so that way we can either assess what's going on in relationship to our recommendations, and or potentially even alter our recommendations based on the practices that we would envision to be there and how they're playing out within a given entity's area if we come to that point. So this helps us in our assessment of the data that we would collect. Anyone else? Evan, Hasla? Sorry, Jack or Hasla. I looked at Jack and said Evan. My apologies.
Nothing for me. That's well said. But yeah, I definitely understand that, there can be, you have to work with others to get some of these answers and things like that. But yeah, the more information we have, the better for us to be able to, assess, what things are looking like out there.
Perfect. Thank you all. We have another question here that reads, given that large loads are in a rush to connect and all the modeling studies cannot be completed in a short time, what are the recommendations of equipment that TOs may require to be installed at this time? We see potential risk, but what are the mitigation measures that one can adopt after the fact, i.e. data center is in service? I kind of want to bundle those questions coming from the same submitter here, as I think it's also related to the amount of equipment that can be installed prior to interconnection and then post interconnection to support the reliable operation of a bulk power system. And knowing that there's a big rush for large load centers, and the DOE letter also is an example for an increasing pressure to integrate additional large loads onto the system. So I'll start with saying that primarily, if you can get a distribution PMU or some other sort of equipment recording device installed on the facility, that will greatly assist in identification of risk associated with that facility for disturbances. I think that being one of the major recommendations here is for communications and disturbance recording to be installed, in addition to other things that the TOs would want to have as part of their interconnection requirements and processes and procedures. However, that's also potentially something that can also be installed after the fact of interconnection. However, it may not, it may follow a different process than the interconnection processes and procedures. And you may have to work with that individual customer to install potentially utility-owned equipment in order to monitor the fault and disturbance-based recording of that facility. So I guess I want to start off with saying, what recommended equipment? I would start with the fault recordings in terms of equipment, and then keep broadening that out into other communications architectures so that operators can monitor and otherwise understand the impacts that facility has on the bulk power system. Evan, do you want to add a little bit?
Yeah, this is fantastic. I was just in a presentation from Dominion this week, and they were really trying to highlight and emphasize that when you have an event on your system, and maybe you saw some data centers or other types of large loads have a customer initiated load reduction, maybe following a normally cleared fault. It is, I think they used the word impossible. You cannot accurately determine what transpired and what was the cause of that reduction unless you have some high-speed recording. So I think at this time, the minimum that people are suggesting is the PMU for a lot of these types of risks around the reduction and being able to understand what that behavior is like. And if you look through our reliability guideline, we also talk about specific other types of devices that may be used to uncover other risks. So one example would be we call out point-on-wave recorders as a potential something that can be used to give much better, higher quality analysis of certain types of oscillations. And so I think some of it depends on the type of facility that you have, but that I think at this time, most folks are agreeing that PMU would be the minimum for any of these types of facilities that may have a fast load transfer or any of those types of risks. So yeah, that's some stuff I wanted to add there.
Perfect. Thanks, Evan. Hosla, do you want to add anything else? Or Jack?
I could quickly add that, identify the risk and then make sure you address that. So that's very important because each risk would have a different, way to mitigate. For example, going on to what Evan shared, there were some incidents having customer initiated load loss, and then understanding why it happened, and maybe there will be opportunities to minimize that from happening if you find the root cause. So you need to measure to understand. And I think that's one big difference we have right now. It's just that we get good data with the measurements, the measuring equipment that's been installed. So that will help a lot, understanding the root cause, but also going into addressing those root causes by there might be opportunities if you understand why the customer initiated load transfer.
Perfect. Thank you so much, Hasla. Jack, anything else?
Yeah, I was just going to add back to that presentation that Evan mentioned from Dominion. I think another thing that looking at Dominion's presentation, it seems that they have learned is that it's with these monitoring devices, having them at the substation level, especially if you have multiple, if that substation is not only feeding that data center, but maybe other things, that there's probably some benefit in actually having that monitoring specifically, at that data center. Not just at substation feeding multiple loads, so that you can do better analysis of events that might be occurring.
Perfect. Thank you all so much. And I also want to agree there with Hasla that equipment should be based on the risk that's been identified as well. And so I think that there's a lot of a risk-based informed decision that occurs through the interconnection process. And I also do just want to highlight, we've heard time and time again that the more detailed recordings that you can get, it helps you articulate exactly what was going on and transpiring in your disturbances. And those disturbances are what highlight us to potential risks to the bulk power system. And the last question I have here right now, and it's appropriate because we only have about 3 more minutes for these questions. Variable speed drives pose challenges within a footprint. I won't read it out loud. Due to their large size and power electronic nature, meeting ride-through requirements can be difficult because of the mechanical system limitations. So how can specific ride-through requirements be defined for those types of systems? So trying to keep it hypothetical and not call out any one given system here. I'll start it off with Evan.
Yeah, so I think that as we look at what the recommendations are out there and across the alert, the various white papers, and now the draft reliability guideline, a lot of this hinges around, and I think you're referring to, what are the potential stability risks based on customer-initiated load reductions that might occur really rapidly. Is that the main focus here is to ensure transient stability or system stability. And so we do recognize that if an entity requires ride through for a specific type of load or all loads, that it could be difficult or impossible for some types of loads to meet that, right? And so I think that's one of the main reasons why NERC hasn't come out and given a recommendation that everyone should adopt ride through for all, for vast arrays of load types, but that we are suggesting that all of these things should be studied as far as it relates to frequency stability, voltage stability, and if a system limit needs to be established, that's established through study with accurate models of when certain loads may reduce their demand or trip offline. So I think I recognize that, yeah, it can be difficult for certain loads to meet certain ride-through requirements. And so we want to lean more towards, is transient stability ensured? And if it is, then, we're accomplishing our job. And so I think that's where I want to leave it. And I'm sure maybe Hasla or other folks want to add to that. So.
Perfect. Thanks, Evan. Hasla, do you want to add something?
Yeah, quick addition is, it's not about, making sure we get a performance requirement for each and every load on the system. Rather, it's about what's the risk associated with that load class. And so just I think being aware of that, because if the risks are different, maybe you need a different performance, or maybe you are not going to mitigate any kind of risk by putting in performance. So just keep your options open as you navigate this. and make sure you base it on solid technical justification. That's what I wanted to add to what Evan shared. Over to you, JP.
Perfect. Thanks, Hasla. I can only agree more. I'll share that past NERC engineering studies have looked at various different ways of ride-through, not for data centers, so this not being a data center specific study, but generally also found that ride-through wasn't the only option for on-fault and post-disturbance recovery. However, there is needs for transmission stability to be maintained throughout those periods. And so there's different methods to accomplish the transmission objective. And so making sure that those are well identified, especially in areas of highly coincident load that is sensitive to these voltage excursions, is heavily important. So with that, we're a little bit over time, but I do want to thank everyone here for holding on for the entirety of the webinar here. If you have additional questions that we were not able to answer during this webinar, you can submit those at the email distribution list that we see here, engineering@nerc.net, and you'll get one of those, or get one of us to be able to answer this. Furthermore, the webinar is recorded, and we'll get a recording and slides posted here shortly. I do want to thank you all for your time and thank our panelists that I was able to rope into to sit here for 2 hours to relate to the level 2 alert and to share and answer many of the questions that we heard here from industry. Again, thank you all. I hope you have a great rest of your day.